Dazza at Race Centre here. Today we're going to talk a bit about valve clearances. We've spoken about valve clearances before in other videos, but today we're going to focus a little bit on what blueprinting is, blueprinting of valve clearances, and also a bit about the checking of them and the measurements and how you need to allow for errors in measurements as well. So first off, I'll start off, for those who don't know, a bit about the valve clearances. If we can get a look in here, is basically we've got cylinder 4 here, but what we're measuring is when the valve is closed. This here is what we call a cam lobe. You'll see when I open the, when I rotate it, you'll see this lobe here is going to push on the bucket, which opens the valve in the motor. So that right there pushes down on this bucket. A little bit hard to see in there, but that's pushing down and opening the valve in the motor. And then when I keep rotating it, you'll see it comes off it. And right at the moment here, pointing up in the sky, that valve's shut. So you can see that shape of the cam lobe is what opens the actual valve. It pushes on the valve bucket. And then now the valve will be shut. So measuring what we call the valve clearances is essentially we're measuring the gap between the back of this cam lobe and the bucket, because at that point it needs to be completely shut. Now, different engines and different specifications actually have the different specification of the clearance. So we're measuring the clearance in there. And the reason that's important is because at high RPM, especially when the engine's revving in its power area, all the components inside the engine, including the valve and the piston and the conrods, are stretching because they're moving at such high speed. A motor like this at peak RPM, the piston will be going up and down 260 odd times a second, so it's extremely fast. And at those speeds, all that's stretching. Now, if there's not enough clearance between the piston and the valve, they'll collide and cause catastrophic failure to the engine. Now, as that valve's opening, they open at a certain speed and what's called the ramp on the cam. But basically that valve will be opening, and if that clearance that you could imagine between the back of it and the valve wasn't enough, as the valve, this inlet valve starts opening, it would start opening too early and the piston would still be right at the top, and the valve would open and potentially hit the piston, which can cause catastrophic failure. So making sure that clearance is in the right area or within tolerance is super, super important for the motor. And it's not just important for race and track bikes, it's also important for road bikes, but certainly for race and track bikes it's a lot more important because they're seeing high RPM all the time, so you need to be on top of that. So measuring that is actually critical, and measuring it can be somewhat difficult. Like in theory it could be quite simple, but it can be difficult, and I'll explain why. So the first thing to understand is that all engines, all different engines will have their own specification for what that clearance needs to be. So I'll get that at a point there, and I'm going to lift that off. Now that's generally the position you check it. I'm going to just show you roughly. I'll grab one of these feeler gauges just for the purpose of this check. So what we do here, we've got these would be all numbered, so that's cylinder 1, that's cylinder 2, that's cylinder 3, cylinder 4. So we're checking cylinder 2 and the first valve, inlet valve on cylinder 2, and that's the second. So we number them all, so that'll be 1, 2, 3, 4, 5, 6, 7, 8. 8 lobes on this because I've got two valves on the inlet side of this 4-cylinder bike. So basically what I'm doing is using this feeler gauge, and they're all numbered, I've got a precise size that I'm putting it in to see whether I've got clearance. So I'll use that feeler gauge there, that one's got clearance, and then I'll keep using different feeler gauges until I get the clearance, until I can't get them in anymore. So this is the first step that gets a little bit complicated, or not complicated, but where you can have potential error. So you're not going to get feeler gauges that are for every fine increment. So when we're talking about increments, what we're measuring here, we're measuring as low as 0.01 of a millimetre. So typically an engine might have valve clearances, let's say the tolerance is 0.12 of a millimetre to 0.18. So you need to be measuring in 0.01 increments. You won't get feeler gauges in 0.01 increments. You can, but they're extremely expensive and they're custom made. So sometimes you're using two feeler gauges together. So for straight away there, the way that you use them, you can introduce some error if you haven't got a lot of experience. Having the right touch to make sure they're going in and one's not sliding on the other and that type of thing. You've got a bit of potential error there. And even getting the correct access, and some bikes are easier than others, but having a bit of the knack for making sure that you're getting those in correctly. That's the first part. And the second part of that part too is that if as they get older, they can potentially wear these feeler gauges, right? So what you do, start measuring that, and then you just keep going up in 0.1 increments until you get to the size that no longer fits. So once, let's just say for example, this was, I'm putting it in there and it's the 0.15 fits, I put a 0.16 and it fits, then I put 0.17 and it doesn't fit, that means my clearance was 0.16. So that's how I measure it first, and as I said, how you use the feeler gauges themselves could be the first part of getting an error in your reading, and then as the feeler gauges wear, that's another potential area to get variation in how you measure. So if we come over here, what we do occasionally, we won't do this all the time, but we do it frequently enough, is you'll see we've actually got two sets of feeler gauges here. And the reason that we've done that, we'll just make sure that we haven't got too much variation in how the feeler gauges are working. So we definitely don't have any variation. We've gone back and forward on these two sets with this particular this job and checking this job. So we're confident that the valve clearance, that these feeler gauges are working okay. You can see we've even got another set here. We actually have all up probably about 10 sets here at Race Centre. Just so that if we've ever got any variation, some of the other technicians using them, we just cross-reference and make sure that it's all working. So that's, like I said, the first part of potential error. The other thing where you can start to get potential errors when I say errors, measurement errors. One of the things I want to say, if you're measuring something within a tolerance of 2 millimetres, it's a lot easier to get that measurement accurate. When you're measuring 0.01 of a millimetre, it is very, very high tolerance. As I said, because of the RPM, because of the valves stretching at high speed, the pistons and conrods stretching at high speed, if you have, like I said, if you get these things wrong, they could clash. And if they clash, you're going to hear a bit of a rattle and things are going to start to get a bit messy and a bit expensive. So very important to get this sort of stuff right. So the next part I want to talk about in potential errors in measurement is the temperature. Most workshop manuals will advise you that you should be a temperature zone that you should be checking, and that's because where everything's engineered to. If it was, let's say, the ambient temperature in this workshop today was 4 degrees, it was a freezing cold Melbourne morning, as opposed to checking it on a Melbourne summer's day where it can be as hot as 40 degrees, and it might be 33 in here, the measurement you're going to get is going to be different. These metallic components are going to be affected by heat, and those measurements will be different. So are the tools, so is everything in this motor is going to be affected by temperature. So it's really important to make sure that you're not getting massive temperature variations. And so a little small thing that you'll see in here, so we keep our workshops as closed as possible. You'll see that it's pretty POV-packed, but each of our workshop actually has a temperature gauge on the wall so that we know what temperature it is in here. And we have things like our strip heaters going there. So the purpose of those is not just to keep people like Bricko nice and warm, which he does. You do like he loves the strip heater. So while they're designed to do that, you'll see other strip heater over there, and even next door in the other workshop. It's to keep it in a relatively comfortable zone. You'll see fans on the on the walls as well. We keep the door shut so that we're controlling the temperature. Sure, between winter and summer, we still have some variation, but not enough variation in the temperature in the room to affect valve clearances. So super important. You won't see us doing valve clearances outside or somewhere in a really cold workshop. Just you shouldn't be doing that. You have to control the temperature. And if you think, oh, really, is it that important? As I said, you're measuring 0.01 of a millimetre. It's almost impossible to get a completely accurate measurement, so it's important to do that. So it's another area that's super, super important. The next thing is, in terms of potential errors in measurement, as I alluded to earlier, the feel for how you use those feeler gauges, and then you can force it a little bit to go in. So it's developing that feel and having that feel. And you'll see that what we do here is an absolute non-negotiable on every job, whether it's a race bike like this one is, or a customer's road bike. Whenever we do valve clearances at Race Centre, we always have them checked by a second technician. Takes longer, it's more expensive because you've got to get it to a point. First technician checks it all, gets it all adjusted, then gets a second technician to check it. The reason that we do that is that if the likelihood of two technicians making the exact same error is almost impossible. So the second technician will go along, do the valve clearance check themselves, and then the numbers are compared to make sure that nothing's too far off. And then the other side of it is as we're training our technicians, like Bricko's our most experienced with doing valve clearances here now, but as the other boys do valve clearances, doing that second check by a master technician means that we're also making sure that they're doing it correctly. So having the second check of the technician is super, super, super important because of, again, the potential for errors. If one technician's a little bit more heavy-handed or too light-handed, you'll pick that up with the second technician doing it. And then with our guys, we actually sign them off at a point to say, you can now do a valve, you can actually do the quality check for somebody else. So Bricko can do that, I can do that, Jules can do that, and Saucy can do that. We all have that level of where we can check somebody else's work. So that's mega important to do that. If you're not having a second technician or second person check them, you've just got to know that you are actually allowing potential error into the checks. Another thing too, so when we go through, and it's hard to go through absolutely everything in detail on these checks, but under those buckets, so we've explained how the cam load works. There's a bucket underneath here, and under that bucket's a shim that sits on top of the valve. Those shims is how you adjust the valve clearance. So if we look at these shims here, so that's a 193, this is what it looks like. You'll see that we've got heaps of all different numbers in all super fine increments. Again, it's an expensive exercise to have for the business to have all of these shims, and you'll see we've got a few different buckets here, and this is only a small part of it. We've got stored in cupboards heaps and heaps more. So we've got this shim, and they'll actually be numbered with what sizes they are. And what that is, a 193 is 1.93 millimetre. So almost 2 millimetres, but it's 1.93. We don't, again, the numbers on the shim could be another potential error. We actually measure them with a micrometer. So you can't measure 0.01 accurately with verniers. Even though a vernier, like your digital vernier might have like 0.01 of a mil on it and it's digital, the whole apparatus of vernier isn't really accurate enough to measure 0.01 of a mil. It's where you need a micrometer, and you need a good quality one too. And again, it's like anything, they need to be checked occasionally to make sure that they're actually measuring correctly. So you need to do that. So this is another tool, and having another tool, if this is out, then your whole measurements can be out. But we measure that with a micrometer and make sure it is a 193. So we do that, and if that was out, once you then put it into the bike and then you start measuring it with the feeler gauges, you'll see that something's wrong because it's not measuring up as it should be. So that's part of what we do. So we measure the clearance first. We do everything for every one of our jobs. We put it into a database. We know what our ranges are in terms of, like I said, whether it's 0.13 of a mil to 0.18 of a mil. We're going to try and land somewhere in the middle, closer to the middle. And this is where it gets important for blueprinting. Sometimes in some places in the industry, it's sort of taught that you've got a min and a max. So if it's, let's say the minimum is 0.12 of a mil. If you can't get a 0.11, or if a 0.11 fits, or sorry, 0.12 just fits in there, then you say, okay, that's fine. It's not smaller than 0.12. And then if 0.18 was the max, you might then get a 0.18 and say, well, I can't get a 0.18 in, so that means it's not any bigger than 0.18. And then you've done a min and max, and that's a quick way to check. But when you start to add in the variations that we're talking about, that the gauge could be slightly off, the technician could be off, the temperature could be off. If you're relying on min-max, when you go to measure that 0.12 and you think it's 0.12, it could actually be 0.11 or even 0.10. The variations can be that big. So what blueprinting is getting those into the middle for starters, and then you're reducing the risk of having a wrong measurement. So even if you're 0.02 out, you're still going to be within tolerance, if that makes sense. So getting it to the exact one. Then the other part of blueprinting is as I said, we've got 8 inlet valves, then we've got 8 exhaust valves. So we've got 16 valves all up. Getting them as close as possible to one another is going to equal more performance. If they're all slightly a fair bit different in that range, the bike's not going to be as efficient, or the motor's not going to be as efficient as it should be. So getting those very close to each other is a performance thing, and then getting the clearances blueprinted and making sure that if you do have errors in your measurement, that it's not going to harm the engine is important from an engine reliability thing. So it's reliability and performance is why it's so important to blueprint valve clearances rather than just do a general check where you're going min and max, which is quite standard in a lot of places in the industry, and what you'll find is different in a performance workshop, a high-end workshop that's dedicated to performance is going to go to that level. So if you do care about your performance bike, your track bike, and your road bike, ask if your valve clearances are being blueprinted and get that information. We actually give our valve clearance sheets to the customers. If you're not getting a detailed sheet of what your valve clearances are, chances are they're not probably being blueprinted to the level that you might expect. And as again, it's up to you. If you love your bike and you want it to be Mickey Mouse, then you'll be wanting to get your valve clearance information and make sure that they're being blueprinted. So the first thing is probably, let's start off with putting them in order, making sure the temperature of the environment's controlled, making sure that you've got good tools in terms of your feeler gauges, making sure that there's a second technician checking it. So even if you're a do-it-yourselfer and that's what you want to do, and you want to learn and do your own valve clearances, bear that in mind. If you're the only person checking it, you've got an element of risk. So take your time and make sure you're doing it properly, because the consequences can be quite large. And then, like I said there, then even if you've got the temperature control, even if you've got a second technician checking, even if you've got great tools available, you're talking about measuring 0.01 of a mil. So there's still going to be the finest of tolerance that you could be slightly out. So by landing your valve clearances towards the middle, you're buying a little bit of contingency either side that you're not going to be out. A min and max for valve clearances, while it's quite common, in our opinion, isn't really quite enough for how important this job is to the longevity and performance of your motor.